Hey math kids, today we're going to talk about homogeneous differential equations, and those are differential equations written in this form where y is dependent on x, and the general approach is to use y equals v times x, where v is also dependent on x. So this first one, dy over dx, x plus 2y over x, we need to first show that it's homogeneous. So what we're going to do is do x over x plus 2y over x, which is 1 plus 2y over x, and that is homogeneous. Now, so to solve for x, we are going to do y equals vx, and if we take the derivative of the left, we get dy dx. If we take the derivative of the right, we're going to have to do product rule. Derivative of v is going to be dy or dv dx. Derivative of just x is going to be 1. So with the product rule, write the first one, derivative of the second one. Write the second one, derivative of the first one. Okay? Simplify that, v plus x dv dx dy dx. Okay, now what we're going to do is compare the two equations that we have for the derivative of x, or derivative of y. So we have this and we have this. So I'm going to set those equal to each other. And I'm going to replace y with this. Those x's will cancel. And then subtract v from both sides. 1 plus v equals x dv dx. And so we need to get v on the same side as dv and x away from it. So to do that, let's divide both sides by x. So we'll get 1 plus v over x equals dv dx. And then we will divide both sides by 1 plus v, or just multiply by 1 over 1 plus v. So that leaves us with 1 over x is equal to 1 over 1 plus v dv dx. So from here, we can integrate both sides with respect to x. Those cancel. We integrate both those. Now, if we want to let's see, let's combine these. So we could think of c as maybe natural log of a different constant, and then we could combine those and say natural log of a x equals natural log of 1 plus v. The reason why we do that is now we can get rid of the natural log by doing e of both sides. And so we get ax is equal to 1 plus v. And if we plug in our thing for v, to solve this for v, it's going to be y over x is equal to v. Replace that v right here. So ax is equal to 1 plus y over x. And then if we want to solve for y, we can just multiply everything by x. So we're going to get ax squared equals x plus y. Subtract x. Ax squared minus x equals y. And a is just known to be a constant. Okay, part B. Substituting y equals, let me just say, so y equals 3 halves and x equals 3. Find the particular solution for these two values. Okay, so if we have our y equals ax squared minus x, and we plug these values in, we can solve for a. 3 squared is 9. Add 3, add 3. I'm going to think of the 3 as 6 halves. So we end up with 9 halves is equal to 9a. Divide both sides, maybe. Divide both sides by 9, which is like multiplying by 1 over 9. 9's cancel, so a is equal to 1/2. And so the particular solution is when we plug it in here. So y is equal to 1/2 x squared minus x. If you have additional questions, please come to Math Lab. Until then, calculator.